LeetCode 309, best time to buy and sell a stock with cooldown. So there is a family of questions which tells you have an array of prices of same stock. You can buy and sell on each if day, but of course you cannot buy the stock twice in the context of the question. So you can buy and then you can sell, but after you sell, you must have a cooldown. So you have a day where you cannot buy again. Okay, but of course you're not enforced to buy in any each day. You need to get to the max price, but you can start with a cooldown. Let's mark it with C. You can start with a cooldown, cooldown, then buy. Cooldown means I don't know, don't do anything. Okay, I cannot have buy then buy. Of course, I cannot have sell then sell. But no one forces me not to do cool down and then cool down and then cool down and then only buy. So we have here a couple of rules on what we can do and what we cannot do. And basically, we need to find the maximum amount of price. So here you see they reached the output of 3, which is the maximum profit that they can make because they first did buy, sell, profit of 1, then cool down, nothing, then buy again, then sell, profit of 2. 1 plus 2 is 3. Okay, so we are having here basically this question. So let's think a little bit about the question. We see that we have an option to buy, an option to cool down. We cannot here sell. If we bought, then we can sell, but we can also cool down. And then, so it's getting like it's getting more and more complex because the option that we choose depends on the option on what we did previously. So I think this gives us a hint. Once we see that we have choices, we have options, we have permutations, we have combinations. All these words should hint us to something. Combinations. So we don't have combination, but we see that this is getting complex. I mean, with each entry, we can choose what to do. Choose whether we buy, not buy, sell, depends on what we want to do. So once we have choices, we should immediately be thinking about recursion. Okay, because we can say if we knew what to do, and some people draw it like with a tree, but I prefer not to draw it. I think this is all we only get us more complex. Uh, because we can say, what if we solved this problem, then depending on the current choice that we make here, we can add the profit. So we have the profit here, and we just need to add. But we need, of course, to know what to do at this step, whether we want to buy or sell. So how do we choose? How do we solve a subproblem with recursion? And and what if in this problem we bought here, so we cannot buy also here? So for that purpose, our recursive function will actually receive the action to do. So let's look immediately directly at the solution. The important thing, the challenge here is first to identify that we are talking about choices here. You can have multiple choices and choices affect the future. And we want to reduce the effort on this problem and to say, what if someone solved us for n plus 1? And if someone solved this problem for n plus 1, then it should be easy only to add this. I mean, right? So let's see how we do this. I mean, it's a little bit tricky because if we add this, then what do we do here? Do we buy? Do we sell? So if we sell here, then we can add a profit. If we buy here, then we remove. This is the trick. Let's look immediately at the solution. Okay. Okay, so this is going to be the solution. We already know that we are going to use recursion. Why? Because we have here combinations, we have choices to make, it's becoming difficult. Recursion to save the day. Okay, so let's look at this. So we have the original function that they gave us, max profit, and the list of prices that we have. In the recursion, we will use immediately a cache in order to make it faster, which would make it DP, but let's not think too much complex now about DP and stuff. It's only a cache. But this would make it DP. So we defined the function of recursion, and if you remember, we said that what do we do in this step? Do we buy? Do we sell? Okay, so let's say that our recursion would handle the if case. Okay, I'm telling the recursion, of course the recursion would need to work on a sub-problem. In an array, what is a sub-problem? Start in an array, especially in an array of days, where you have day 1, day 2, day 3, what it would be a sub-problem? Solve from day 3 and on. So here we say from which day do we want the recursion to solve us the problem. But the issue is that if we are coming from I-1, if we are coming to this recursion from I-1 and we already bought, then can we buy on I? No, we cannot buy. So we are going to pass a flag whether it's possible to buy on the day of I or not possible to buy on the day of I. That's it. And we know whether it's possible to buy on the ith day or not to buy on the ith day because we are coming to recursion from the past. And if we bought something on I-1, then we cannot buy. If we sold something, then we cannot buy on I+1. We can only buy on I+2. If we are coming from a cooldown, then we can buy. Okay, so we are going to work with this. So for that purpose, we pass two parameters to the recursion, the subproblem, the ith day to solve for, and whether we can buy or not. Let's even, before we start with edge cases, let's go. So we have two cases, right? We have a case where we can buy, and we have a case where we cannot buy. Okay, if we can buy, then what are the options that we have? We can buy, but we can also cool down, right? If we cannot buy, then what are the options? Either to sell or to cool down. Okay, because we can sell, but we can decide not to sell. Both of these we would give to the recursion to solve for us. We are not solving. We are not going to solve for I+1. We are going to let the recursion to solve for I+1, and I think it's easier to think of it this way than to draw the tree and to get complex with it. Okay, so if we can buy, we said that we can buy, and then we ask the recursion, hey recursion, please solve it for I+1. But can you buy on the day of I+1? Of course not, because we just bought, so we can't buy the stock twice. And because we are buying for the ith day, okay, remember, we are telling the recursion, please solve for I+1, right? Solve me for I+1, but I will solve for the ith day, for the current day. This is what I will append. Because I'm buying decided to buy on the ith day, then I'm removing the price of the ith day from the general profit. Okay. So if I'm buying, I'm removing the price from the ith day, and I'm telling the recursion, please solve for I+1, and you cannot buy. If I'm cooling down, then nothing happens on the ith day. So I have nothing to add or to remove, but I'm still asking the recursion, please solve for I+1 day. Can you buy? Yes, you can buy. Because remember, the argument is only whether I can buy today. So if I can buy today, and I'm cooling down today, then I can also buy tomorrow. Okay, and now we are saying, okay, so I solved for I+1, but I solved in two cases. What is going to be the best case, the max profit, the maximum? of whether I bought on the ith day or whether I cooled down on the ith day. And I add it to the cache. We see we have a nice trick here in Python to add a tuple to the cache. So I know for the ith day and for whether I was able to buy or not, what was the max profit. Now, if I cannot buy today, what is the reason I cannot buy today? If I'm coming from a case, you see here, I came from a case where I bought on the previous day. So I'm passing an argument, cannot buy. Then either sell, if I'm selling, then I'm going to add the price of the ith day, and I'm going to tell it, okay, solve now. So you cannot, there is no reason to solve for I plus 1. Because if I solve today, you have to cool down tomorrow on the I plus 1. And if I will add another parameter of if can buy or if cannot buy, this would make this super complex because we would now have to deal with 3 states. So this is a trick to avoid cooldown state. I already have can buy or cannot buy state. I don't want another state. This would make things super complex. How do I avoid this additional step? I just tell the recursion, go ahead. I'm going to sell this. Tomorrow you cannot do anything. Solve it for I plus 2. Tomorrow you are cooling down. Can you buy on the I plus 2 day? Yes, because tomorrow on the I plus 1 you cool down and I just sold, so you can buy. So you see, I told the recursion, solve it, but the trick here is that I'm telling it not solve it for I plus 1 with cooldown. I don't have a state here cooldown. And if I had a state a cooldown, I needed to know whether I bought previously, make things super complex. The trick is to know, to ask the recursion to go for the I plus 1 day, and then you can buy. It's okay to buy. And because I sold now, then I'm adding the price of I. Now I can, if I cannot buy, this means I have the stock. Okay, I have the stock. I have stock, right? If I have stock, I can sell, but I can also cool down. If I cool down, I do not add anything. You see here, I don't add anything for the current day. And I'm just telling the process, I'm cooling down today. You know what? Solve it for the next day. Can you buy? No. Why can't you buy? Because I hold. This is the case where I hold the stock, right? Hold stock. Have stock? No stock. So if I have stock, I can buy. If I don't have stock, I can buy or I can cool down. If I already have the stock, I can sell or I can cool down. And now also in the case of selling or cooling down, then I'm saying that the max profit for I and can buy state would be the maximum of either sell or cool down. So important thing to see here is that we are asking the recursion, I think it's better than drawing a tree, we are going to ask the recursion, hey recursion, solve me for the reduction of the case, solve me for I plus 1 or for I plus 2. And I will tell you whether you can buy or not. And the state is simple. It's either you can buy or you cannot buy. If you can buy, then either you buy or you cool down. If you cannot buy, then either you sell or you cool down. Actually, I think this state, maybe I could rename it to I currently hold a stock. I currently hold a stock. So if I currently hold a stock, then I can then I would be here. Then I would be able to either sell or cool down. And if I don't hold the stock, then I could either buy a stock or cool down, and I would handle the case of selling, and then I have to cool down with the I plus 2. Okay, so we have updated the cache. We are beginning to call the recursion from 0, item number 0, and we can buy. It's okay, we can buy the first, or we could rename this to not holding a stock. This is the state. This could be even a better representation of the state. I'm not holding a stock. Now we need to handle also the edge cases. So if the I that you asked me to solve for is beyond the array, then return 0. I have nothing to do. If the I and can buy is already in the cache, Then just return the state from the cache. Do not even bother about calling the recursion. So that's it. That was it for the max profit. Having a cache, which makes it DP. As you see, the DP here is simple because it's just a matter of identifying the recursion. And sometimes you can identify the recursion by just identify which subproblem you can solve even without seeing it in a tree picture. In this case, the subproblem to solve, because it's an array in future of days, then solve for the next day, also for the second day, because we avoid another state here. So you see, so this was the how to solve it. And of course, this recursive function needs to return something because this recursive function will return the max profit that it can get. This is the recursion. Solve for I and whether you can buy, but tell me what is the max profit from this I day. So we already have this because when we solve here inside the recursion, we say that we solved it here and we return the cache I and can buy. So this was it for the question of 309. Best time to buy a sell stock with cooldown.